Hey y'all, Mr. Nicol here to talk about bar models. Part 1, talking about the part-whole model. So bar models, if you've seen from our other videos, are one of the core ways that our curriculum for math uses to help kids conceptualize visually what is happening in their arithmetic problems. Now the simplest kind of bar model we have is what's called the part-whole model. In the part-whole model, you will be shocked to discover involves multiple parts that come together to make a whole. So here we have, for example, a part-whole model to describe the number of people that are in a class. Say you have a class that had 10 people at one point, and then 3 new students joined. You want to say, okay, well, how many people are in it now? Well, you can draw a rectangle that shows, here's all the people. This is a pretty abstract way of drawing all of the people that are in the class at the end of the class, but you know, you understand it. It's longer. If it was shorter, it would be fewer people. If it was longer, it would be more people. Now let's divide this. Let's say that this rectangle is all the students. All students. And we don't know how many that is. That's what we're going to have to figure out, because we know that there were 10 and then 3 more joined. And so we'll put a question mark there. We want to know how many all those students were. Okay, well, we can subdivide that then into, this is the whole, into the 2 parts, because it's the part-whole model. Sometimes it's called the part-whole model in case you forget that there is more than one part. So here we have, this one looks bigger. Let's say that's our 10 students. Students who are already there. Say, already there, 10. And then the students who, new arrivals, there are 3 of these. Now, this seems like a whole lot of work for a fairly simple problem. I get that. It's very helpful for a number of things. First is, way down the line, this will be really helpful for teaching multiplication, for teaching exponents, for teaching division, for teaching all kinds of mean, nasty, ugly things. It's also really helpful for word problems or any problem that deals with the, messy realities of life, and then you're asking kids to abstract them into, transcendent pure mathematics, and figuring out what that transition is often very difficult. And so giving a picture as sort of an intermediary, you're like, oh, I've got the 10, I've got the 3, do I take away the 3 from the 10? Do I multiply them together? What do I do? It's easy to look at and be like, oh, well, there were this many, and then this many more showed up. These are my 2 parts, and so, I add those together. Great, 10 plus 3. It helps students keep straight in their heads what's going on. It's also really helpful because it attaches what these things are to the numbers. If you learn a word problem to approach it just as like, here's the word problem, okay, well, I'm trying to figure out 10 plus 3, that's what I'm trying to figure out. Oh, well, 13, hooray. Well, it's 13 what? We're dealing with the real world. And I will say, as a science teacher also, this is so helpful for the students who learn this, because once you get into science classes where you're having to do math, and you're multiplying meters by kilograms times the force of gravity for something to find joules. When students have just learned to use the numbers and have actively learned to divorce the reality of, what these words are, what it's describing from it, then they have a much harder time solving those fancy science problems than when they remember that, oh, this 10 isn't an abstract 10. This is 10 students who were already in the classroom. So this is the part-whole model. You've got your part, there's the whole. If you've got what you call a missing whole problem, such as this, then you know I add the parts together. You might have it also if you said, okay, well, there were 13 students in the classroom, 3 of them arrived late. How many were there beforehand? And so I've just changed, this is what we know that. I've put a question mark here. Because again, drawing out this model is a clear way for you to identify what's the thing that I don't know? What are the things that I do know? How can I use the things that I do know to find out what I don't know? Say, okay, well, 13, 3, well, I shouldn't be adding that on because this is part of the 13, so I must be subtracting the 3 from the 13 to find this amount. I know that there aren't any students who weren't either already there or showed up late, new students. And so if I subtract this, then all I'm left with is that part there. Oh, okay, well 13 students minus 3 students is 10 students. So that's big picture how the part-whole model works.